Okay, welcome back to the Algebra 2 notes for section 4.3. We're on page 3 this time. So what we're doing in this case is solving for this variable x, and you'll notice that a capital X is used, an uppercase X. That means that our answer that we're looking for will be a matrix. So we're going to have something with brackets around it when we're done. Now the first thing we want to do here is to get the X isolated is take the matrix over to the other side along with the 2 that's in front of it, and you'll notice that when you do this, this minus sign becomes a plus sign is the only change you make when you take it over. You want to be careful not to change too much. You don't want to change those numbers when you bring it over to the other side. That would be like taking and doing a double change. Okay, next you want to take care of the multiplication. You can see that I multiplied the 2 throughout that second matrix. So this 2 times the 4 gave the 8, for instance. And then once we've done that, we're going to add these 2 matrices on the right. So that'll be the next step. And you can see I've gone corner by corner. For instance, the top right corner is 5 plus -2, and I put a 3 in that position. All right, now at this stage, all we have is 3x on the left. In regular algebra, you would divide both sides by 3, but we don't allow division in this section. So what you're going to do is multiply both sides by the reciprocal. And that takes us down to this line. On the left, you're left with just x. And on the right, you've got a scalar multiplication. You're multiplying by 1/3. And so you're going to go 1/3 times 6, 1/3 times 3, and so forth. And your final answer here is the matrix 2, 1, 0, 4, that little 2 by 2 matrix. Okay, off to the right, there is another example of this sort of process. And we're going to start by taking the little matrix 3, -1 over to the right side. You can see that when I did that, I changed the sign in front of the matrix to its opposite. That's similar to what we've done before in algebra. And next, we're going to combine those matrices with subtraction. So the top element is 7 minus 3 gives 4, and the bottom is -3 minus -1 gives -2. Okay, at this stage, we're going to have to get rid of the 2/3, and you do that by multiplying by the reciprocal, 3/2. On the left-hand side, we got a bunch of stuff canceling off, and we end up with r. And then the matrix multiplication on the other side, scalar multiplication, 3/2 times 4 would be 6. And then 3/2 times -2 is just -3. So your answer here is the little matrix 2 by 1 matrix 6, -3. Okay. The major division in this note set happens at this point. We're going to learn how to multiply not a scalar times a matrix, but 2 matrices together. And you can see here in this first example here, we have 2 matrices being multiplied together. Now, I'm actually not going to show you how to do this until I show you when it can be done. How to do it will be on the next video and the next page of these notes. So we're answering a different question. When can matrices be multiplied? And the answer here is a little strange. Unlike adding and subtracting where you have to have the same size matrices, here you don't. What you have to have here is the number of columns in the first matrix matching the number of rows in the second. So let me illustrate that. We're going to find out if this first example is even possible. We have a 3 by 2 matrix times a 2 by 1 matrix. Now, the number of columns in the first matrix needs to match the number of rows in the next matrix. And we can see that these match. So what we have here is a situation where the product of those matrices would actually give an answer. It's defined. I haven't shown you how to do it yet. And there's one other piece of information that you'll get out of this. The outside numbers together give you the size of your answer. So these two matrices would multiply to give a 3x1 matrix. And that outside pair, the original row and column of the first and second matrix, that's the size of the answer. So let's do this again over on the other side. Example B. We're starting out with a 2x3 matrix. The other matrix is a 4x3. The two inside numbers, the column value for the first matrix and row value for the second, do not match. And so this would give an error if you tried to do it on the calculator. It's undefined, and there is no such product. This doesn't have an answer. Okay, so we'll pick up on the next page, on page 4, and on that page I'll actually show you how to do this multiplication.